Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will continue our discussion on Fourier series, where I will show you a solution to another sample problem, on Fourier series representation of a signal. So in this question, you are given this signal 2 cos pi t over 4 plus 3 sine 2 pi t over 3. And you are asked to first determine the complex Fourier series coefficient of x of t, or the exponential Fourier series representation. And number 2, using the result that you found in number 1, determine the trigonometric Fourier series coefficient of x of t. So let's solve this problem. So you are given this signal x of t equals to 2 cos pi t over 4 plus 3 sine 2 pi t over 3. So in order for us to represent this signal in terms of the exponential Fourier series representation, first you have to remember this, this theory where if you have a signal cos omega o t, it is equivalent to this equation in the exponential complex form. If you have a sine signal, sine omega naught t, it is equivalent to this form in the exponential complex. So now we have this signal. So let's represent this cos and sine function in terms of the complex exponential. So you have x of t equals to 2 multiply with ej. Omega naught is pi over 4. So pi t over 4 plus e minus j pi t over 4 divided by 2 plus 3. Now we have sine signal. So we have ej, the omega naught is 2 pi over 3. So we have 2 pi t over 3 minus e minus j 2 pi t over 3 divided by 2j. Now this one can cancel out, and let's expand this signal. So we have j pi t over 4 plus e minus j pi t over 4 plus 3 over 2j e j 2 pi t over 3 minus 3 over 2j e minus j 2 pi t over 3. So now this one, let's call this signal T1. Let's call this one T2. This one T3. And this T4. And we know that the general form of the exponential Fourier series, exponential Fourier series transformation is given by this equation. X of t equals to summation from n equals to 1 until infinity dn e j n omega naught t. So the next step that we have to do is to determine omega naught of t, where this omega naught of t is the radial frequency of x of t. So in order to find the radial frequency of x of t, first we have to determine the period, which is t of x of t. And we can do this using the least common multiply method, because x of t here It consists of the summation of two periodic signal, the cos and the sine signal. Okay, so I have explained how to use the least common multiply method in one of the earliest lecture. Okay, so if you can't remember how to do that, you can refer back to the video where I discuss periodic signal. Okay, so for 2 cos pi t over 4, okay, the radial frequency of this signal, let's call it omega 1, is pi over 4 radian per second. So the period for this signal, let's call it t1, is 2 pi over omega 1. So this one is 8 seconds. For the second signal, 3 sine 2 pi t over 3, okay, let's call the radial frequency omega 2 is equals to 2 pi over 3 radian per second. So the period for the sine function is 2 pi over omega 2, so is equals to 3 seconds. Okay. So now you have to use the least common multiply method. So we have two number, 8 and 3. So this one is equivalent to 2 times 2 times 2. And this one is 1 times 3. So you will get 1. This one equivalent to 8. Okay. So the LCM is equals to 2 to the power of 3 here, because number 2 here occur, the frequency is 3 times. Okay, multiply with, here you have 3 but occur only 1 time. So 3 to the power of 1, and multiply by 1 also occur 1 time. So here is equivalent to 24. Okay, so the period for this signal is, for x of t, okay, the period for x of t is 24 seconds. So omega naught, which is the radial frequency of x of t, is 2 pi over 24. So is pi over 12 radian per second. So now we want to substitute this value of omega naught t into here. Okay. And then once we do that, we wanted to compare this general form of the exponential Fourier series representation with T1, T2, T3, and T4. Okay, in order for us to determine what is n. Okay, so let's do that one at a time. So for T1, the general form of the exponential Fourier series is Jn pi t over 12, equivalent to T1 is Ej pi t over 4. Okay, so we wanted to compare this part with this part. Okay, so you have n pi t over 12 equals to pi t over 4. So n is equals to, multiply with 12 over pi t. Okay. So in this case, for T1, n equals to 3. Okay. Now for T2, the general form of the exponential Fourier series is the same, n pi t over 12, but T2 is e minus j pi t over 4. Okay, so we will have n pi t over 12 equivalent to minus pi t over 4. Okay, so n is equals to minus 3. Next, for T3 is j n pi t over 12. This one equivalent to e j 2 pi t over 3. Okay, so you have n pi t over 12 equals to 2 pi t over 3. Okay, so in this case, for t3, n is equals to 8. Okay, now for t4, the general form is the same, but this one for t4 is minus. Okay, so you have with minus, so in this case you have n equals to minus 8. Okay, so what is the function of this? Now you will have, if you remember the x of t, okay, the general form of the exponential is like this: infinity dn e jn pi t over 12, right? So this is the coefficient. This dn is the coefficient of the exponential Fourier series representation. Okay, so now we have n3 minus 3, 8, n minus 8. So means you have d3, d minus 3, d8, and d minus 8. So you want to determine what is the value of this. Okay, so if you look here, for t1, the multiplier at the front here is 1. Similarly, for t2, the multiplier at the front here is also 1. For t3, the multiplier is 3 over 2j. And for t4, the multiplier at the front here is minus 3 over 2j. Okay, so therefore, d3 is equals to 1. d minus 3 also equals to 1. d8 is equals to 3 over 2j. Okay, because you obtain n equals to 8 from t3. Okay, and d minus 8 is obtained from t4. Then the multiplier for t4 is minus 3 over 2j. Okay, so this is the answer for question number 1, which is the coefficient of the exponential complex exponential Fourier series representation. Now, we are asked to determine, okay, from the result that we obtain here, we are asked to determine the trigonometric coefficient of the Fourier series representation. Okay, so this is number 2. Right, so for the calculation, okay, this one I already discussed in the slides on Fourier series discussion. So we have an equals to 2 multiply with the real part of dn. And bn is equals to minus 2 times the imaginary part of dn. And a0 equals to d0. Okay, so you have to remember this. So in our case, a0 is equals to d0 equals to 0. We don't have the constant value. Okay, so we have a3. Okay, because we have d3, d minus 3, d8, and d minus 8. So we have to find the equivalent of each of these. So for a3 is equivalent to d2 multiply with the real part of d3. Okay, and remember d3 is equals to 1, which is also equivalent to d minus 3. Okay, so we have, in this case, e3 equals to 2 multiply with the real part of d3. So here d3 we only have real part, which is 1. So multiply with 1, you have 2. B3 equals to minus 2 times the imaginary part of D3. Okay, so B3 equals to minus 2 times D3 doesn't have imaginary part. Okay, so it's multiply with 0 equals to 0. So A3 equals to 2, B3 equals to 0. Now A minus 3, same, 2 multiply with the real part of D minus 3. Again, D minus 3 is equals to 1, okay, from the previous calculation. So, and this is the real part. Okay, so equivalent to 2. B minus 3 equals to minus 2 times imaginary part of D minus 3. Okay, again this one will be 0. Okay, because D3 here doesn't have imaginary part. Now A8. Okay, now D8 is equals to 3 over 2j. Right? So real part of D8. This one equals to 0. 2 times 0, because D8 only have imaginary part. Okay, multiply with j. So this is imaginary part. It doesn't have a real part. So this one equals to 0. B8, which is equals to minus 2 times the imaginary part of D8. So this one will be minus 2 times 3 over 2. So this one cancel, you get minus 3. Okay. Now A minus 8 equals to 2 times the real part of D minus 8. Again, this one is 0. Okay, because D minus 8 equals to minus 3 over 2j. Okay, it doesn't have real part. B minus 8 equals to minus 2 times the imaginary part of D minus 8. So we will have minus 2 times minus 3 over 2. So this one will be 3. Okay, minus 2 and 2 cancel out. Okay, so these are, okay, so you have here A3, you have B3, A minus 3, B minus 3. These are the coefficient for the trigonometric Fourier series representation. Okay, so this is the answer to question number 2. And so that's all for video on Fourier series. I will see you in the next video where I will discuss Fourier transform. Thank you.